Okay, so in this video, we're going to talk about r squared. So we looked at r squared, we briefly mentioned r squared in the first video when we talk about it, but it's one of our measures of kind of how well the model fits. So if you go down here, this is kind of where r squared shows up in our particular model that we looked at last time with the verbal and percent. And we briefly mentioned that it has to do with how well the model fit. So we'll talk more about it this time. S we kind of know too, right? S we're kind of familiar with. S is sort of the standard deviation. R squared is, as we'll see in a minute, is also kind of a measure of how well the model fits. Okay, so definition of r squared. So one definition is r squared is just the square of the correlation. Okay, so we had correlation earlier on in Stat 110. When you have simple linear regression, simple linear regression here. So in other words, when you have the model y equals a plus bx, then r squared, this r squared thing, is just the square of the correlation we saw earlier. So we'll do an example of that with that data in a minute. The second definition is r squared is the variation or spread in y explained by the regression relationship or by the regression model, the equation we've got here, divided by the total variational spread in y. Actually, we'll look at that too. We'll see how that actually works. We won't do the math of it, but we'll hopefully figure out how that works. R squared also measures how well the x or x's, our predictors, explain the changes in y. Right, the response. And we'll see if r squared is equal to 1, that means perfect explanation. The regression model equation goes through all the points. R squared equals 0 means the regression model explains nothing. So that kind of shows us right there. We're not going to look at, again, we're not going to worry about the math of it, but come on, there we go. R squared is a value between 0 and 1. Minitab here, as we'll see, makes it a percentage. Makes it from 0 to 100%, but really it's a value from 0 to 1. So let's go ahead and, I'll get a little bit lower there. Well, that first one first. So we'll look at this first thing here. R squared is the square of the correlation when you have simple linear regression. So let's look at an example here. So in this example here, we have simple linear regression, right? We have our model is SAT verbal SD verbal is just 485.4, so 485.4 minus 1.105 times percent, right? That's the model we've got here. And we're given r squared in terms of values from 0 to 1, if not percentage, it's going to be 0.744 approximately, 74.4%. So we're going to find the correlation between our two variables. So between SAT verbal and percent. Okay, so I have to be a little careful here. The correlation, since we have just a straight line model, a y equal a plus bx, is the square root of the correlation. Square root of the r squared, right? R squared is the square of the correlation. So r, the correlation, is the square root of r squared. But be careful, right? Because it could be positive or it could be negative. If you think about it, right, 2 times 2 is 4, but also negative 2 times negative 2 is 4. So when you take a square root, you have to write about positive or negative. So for this example, we're going to have r equals the square root of r squared 0.744. But the question is, do you want positive or negative the square root out in front here? Well, what gives us that is the sign, right? Here, the sign of the slope. The slope is negative. So a negative slope means the correlation has to be negative too. So in other words, just look at the sign of b. So the sign of b, the slope, tells you whether you want positive square root or negative square root. So here we want the negative square root because that slope is negative. So it's going to be a negative correlation. So let's go ahead and calculate that. So 0.744 square root. Make sure I got enough. 0.744 square root. There we go. I get, change to blue again. Negatives, the negative sign out front. 0.8625 and some other stuff. Dot, dot, dot. But we can check that. I still have Minitab that we used last time. So I have the Minitab up here, so I can open it up. So here's the Minitab. Here's the actual data, right? Our states data. And we're looking at verbal and percent, right? We're looking at those two. So I can do stat, maybe under stat, basic stat, this correlation down here. So I can do stat, basic stat correlation. And I want correlation between verbal and percent. I don't want the p-value. That you see, remember we talked about this with the correlation. You don't want to put the p-value in there because it can confuse you. What's the correlation? What's the p-value? Because a p-value can look like a correlation. So click OK. There it is. For Minitab, let's copy that. Put over here. And you have to, if I put it in there, feel careful. Let's see, where is that? There we go. I'll insert it. Let's paste in there. So there we have the correlation from Minitab, which gives us a similar value, right? So we got negative 0.8625. They got negative 0.863. Same thing. So we got the same, which makes sense. It's only a slight difference because we used the r squared value equal 0.744, which isn't the exact value, right? It's a rounded value. So this last 4 is rounded. That's why I got a slight difference. Here, if I round this 5 up, I get the same thing as this r squared down here. So that's one definition of r squared. I'm going to just scroll down here for a second, get this out of the way. There we go. Get back up here. Now I can probably do the rest. So that is our, a little bit higher here, our first definition, right? And that's only when we have the regression model y equal a plus bx, a simple linear regression. The second definition of r squared says that the variation or spread in y explained by the regression relationship by the model divided by the total variation or spread in y. So another way to interpret the r squared here, which is actually a nice way to interpret it, the r squared itself, this 74.4% tells us that 74.4% of the variation, or in other words spread, in the y, the st verbal, is explained, let's get a better explained there, is explained by the equation or model SAT verbal equal 485.4 minus 1.105 times percent. So that's what this R squared value of 0.744, 74.4% tells us. That's what this number here tells us. Okay, so that's the sort of second definition. That's the one that works all the time. That's how we interpret it all the time. The R squared is the percent of the variation or spread in the Y explained by the model. The other one, where we found the correlation, only works when we have the simple linear regression, the straight line model. But this always works. So next we're going to look at seeing how to calculate R squared. We're not going to do it exactly. We're not going to do it all numbers, but I can kind of hopefully show you visually kind of how it works. Those of you with sharp eyes may notice some of the writing has changed because I had to switch here from a docx document in Word to a document to allow it to actually draw on the picture up here. I want to draw some lines on the on our graph up here, and the docx wasn't letting me do that, so I had to kind of change it a little bit. So how do we find R squared? Kind of what is it calculating? How does it work? So first thing we need from Minitab or from another source is we need the mean or the average of the Y values. So that's easy enough to get in Minitab. So our Y is SAT verbal. So I'm going to do stat basic stats display, and I want the verbal. So it's already in here because I tried earlier. Click OK, and I want the mean, the average of the Y's. So the average of the Y's here is 448 and a bit, 448.16. Okay, so what I want to do now is I want to go, okay, I'll make it black and use the pen here. So I want to make sure it's black, there we go. Put a line here at approximately the best I can, straight as I can, at the average of the Y's, which is 448.16. That's the average of Y's. If you want to call that Y bar, that's the average of the Y's. And now I'm going to find some distances. First thing I'm going to do is I'm going to find how far each point is from that average of the Y's. So I'm going to do a few here, but really you do this for all the points, not just some of them that I'm doing. You do it from all the points. So some are close to the average and some are further away. So I'll use black lines for those ones. So I'm finding how far the points are, all the points, not just few that I'm doing, but all the points, how far all the points are away from the average, the Y. Another distance I'll find, I'll use blue for this, and you'll see in a minute why it makes sense to use blue. I'm going to find how far the points are, these Y values, are away from the model. So those are blue distances. So since the regression line is blue, I'm using blue distances for these ones. And again, I should do it for all the points, not just some of them. But again, it gets too messy if you have it for all the points, but hopefully you get the idea. You're finding how far these points are away from their average and how far the points are away from the regression model. Let's do a couple more here. There we go on, and let's do another one here. Okay, so you have these blue lines, these black lines. The distances from the points from the regression model, those are the blue lines. The distances of the points from the average of the Y's, their average, that's the black lines. So what does R squared do? How does it calculate R squared? So let's get a little more room down here. We can still see some of those lines here. So what does R squared calculate? So let me use a different color since I'm going to be using both blue and black for those lines. So R squared is the sum of, I'll put parentheses here, minus the sum of, put a parenthesis here, divided by the sum of another parentheses. Okay, what are these parentheses for? Well, we're going to take those lines. So what I'm going to do, change the color here to black. I want to take the sum of those black lines on top and bottom, and guess I'll do this in red. So I put a little quote around it, so it's that distance, whatever it is, and I square those things. I square those distances. Likewise, I'm going to get those blue lines and square those distances. Actually, maybe I put a double quote in here so we can see those quotes there. Kind of see those. And those on the blue distances. Oop, get the right blue here. I want the other blue. There we go. That's what R squared is doing. It's summing up those black distances. So those black distances. So this is the these are the distances from, get a bit better from here. You get used to this other one that's writing. Distances from the y values to their mean, which is the y bar, and the blue distances are the distances from the y values to the regression equation or regression model. So what R squared is doing is finding the total distances. Let's go up a little bit here. So R squared here is finding how far are all the values from their average, and adding those, squaring those distances and adding them up. So some are positive, some are negative. They're squaring it to make them all positive, adding them up. It's then finding the regression model and saying how far are the points from the regression model, squaring those, adding them up. And the actual calculation of R squared calculates this number. So each of those distances, each of those black and blue lines are numbers. And it does this calculation. That's what R squared is calculating. Some other things to hopefully make it a little more sense out of this. The blue lines, get the blue lines back here again. The blue lines are called residuals. We'll use them later on. They're the leftover or unexplained distances, right? Those things we haven't explained. So what regression does, it's actually called least squares regression. So regression finds the best model or equation. Oh, that's a little too messy there. Try to do the equation and the parentheses at the same time. The equation. So regression finds the best model or equation to minimize the sum of those residuals squared. This blue line squared. Ooh, wrong color. The other blue. Here we go. Or in other words, regression finds the best model to maximize the value of r squared. So it tries to maximize the r squared value, which makes sense. It tries to maximize this percent of the variation explained by the model. Because note what's true here. I'll say this. Hopefully it makes sense. The blue line distances, the residuals, they change from, let's make it better, from regression model to regression model. But the distances from each of the points to their mean, the black line distances, don't change. So if you go back up to our picture, scroll back up to the picture, notice that black line there, the average of the y's, that is fixed for those points. That doesn't change. So the black lines, the distances from the y values to their mean doesn't change. That's always the same for that given data set. But if I change the regression equation, if I change that line, if I move the line around or change it to a slope or something, the blue distances are going to change, because those are how far they are away from the regression model. But the black line distances don't change. They're fixed. So that's kind of how regression works. It finds that best blue line, the blue line that makes the sum of those residuals squared, those blue line distances squared, as small as possible, which is the same thing as making r squared as big as possible. The percent of the variation in the y's explained by the model, the r squared, as big as possible. Another way to think about what r squared is doing, the sum of the black lines squared, that is really all the variation in the y's. The sum of the blue line squared, that's the unexplained variation, the leftover variation. And if you divide by the sum of the black line squared, it just scales it, puts it out about 100%. So really all we're doing here, if we take all the variation minus the unexplained variation, it leaves us with the variation that's explained by the model, which is our definition of r squared. That's all we're doing here. So don't worry about putting values in for the blue lines and the black lines, but hopefully get the idea of what it's doing, of how it's trying to calculate this r squared value. One thing I guess we'll finish with, I'll show you, that we had up earlier. We said that r squared equal 1 meant perfect explanation, right? And r squared equals 0 explained nothing, and r squared went from 0 to 1. Well, notice if you have perfect explanation, if r squared is equal to 1, if you go to our formula for r squared, how can this formula for r squared, the sum thing, equal 1? Well, notice, I'll write it down here. I think I've got room where you can still see that. Yeah, just about here. I'll use black this time or something else. Yeah, let's just regular black. Notice, if r squared is equal to 1, that means in terms of our what we have up here, the sum of the blue lines, I guess I have to use the red again, I guess. R squared equals 1 if what's true? Well, if the sum, the blue line, so I guess I need the red first, let's do the red, the sum of those blue lines squared equals 0, right? If those blue lines squared is 0, there's no blue lines there, then r squared is equal to 1. Because all we have in that case is the sum of the black lines and squared over the sum of the black lines. And that's exactly the same as no blue lines. Which means the regression model, or the regression equation, goes through all of the points. There's no leftover distances. Let's make that model a little better. That's a pretty ugly model there. So that's what we said. R squared equal 1 means that it goes through all the points. And now we know why. Because it means there's no residuals. There's no leftover distances. It hits all the points. Likewise, or similarly, when's r squared equal to 0? Well, r squared equals 0 if what's true? Whoop, let's get a better if there. Or if you go back to the equation again, the only way r squared can equal 0 is if the top is 0. And the only way the top can equal 0 is if the sum of the black line squared equals sum of the blue line squared. Right, that's the only way. So it can only equal 0 if the sum of the black line squared equals the sum of the blue line squared. So let's put the black and blue in there. And the only way that can happen this can happen is if the regression model or regression equation is just the mean of the y's. So in other words, the regression model is y equals y bar. In other words, visually all we're saying here is r squared equals 0. The worst case scenario is the regression model, that blue line, the regression model, just becomes that black line at the average of the y's. That's the worst case scenario. That gives you an r squared of 0. It tells you nothing, because the model is just the average of the y's. That's the worst case scenario. Okay, so hopefully that gives you a little bit of understanding of r squared and what it's telling you, at least visually. And so next time we'll actually start playing a little bit more around with regression models.